representing program operations, right? Now, so in this second step, I think you are following the most of the students are using the second point before writing the program. What is the second step in your language in the technical term? Addition or none. So what is the in that formula? Plus arithmetic operation plus. Right. That means formulas. Write down. Formulas are sequence of instructions arranged in suitable manner. దీన్ని ఏమంటాం? షూటబుల్ ఒక ఆర్డర్ లో పెట్టేదాన్ని డయాగ్రామ్ ఒక డయాగ్రామ్ అంటాం. ఫ్లో చార్ట్. వెరీ గుడ్. ఇట్స్ కాల్డ్ ఫ్లో చార్ట్. Or algorithm. Before implementing the any programming any problem statement, we have to do the algorithm, right? Algorithm. In sometimes the algorithm is also called flow chart. Actually, the flow chart and algorithms are different. Flow chart is for the development of software, algorithm for development of hardware. You are not developing the hardware, so you can consider both are similar, the algorithm and flow chart. So after finding the problem statement, then flow chart, right? Simply the second point is flow chart. Flow chart or algorithm. Third step, after finding the algorithm, then suitable. Choose suitable instructions. Choose suitable instructions, right? So here, in our case, we are calling as instruction set. Next, fourth point, write a program. Write a program. After writing the program, save that program using suitable dot extension. Okay, so these 4 steps are using to develop the any program, to define the any problem statement. Okay, so in our case, we are writing the simple programs on basic processor, that is the 8086. Anybody can differentiate the C language to Python? I think both are purpose is same, right? C language and Python. But Python is somewhat advanced version. Okay, what is the difference between the C and Python? Interpreter, compiler. In C language, the interpreter and compiler both are different. In Python, only interpreter directly. And the Python language similar to our English language, right? But the C language, we have to follow some steps, some sequence. Ante basic nunchi advanced kelle varaki our language are easy. But if you are understanding the basic language, the advanced very, very easy. So we are doing the same. So we are implementing the basic level programming, that is using 8086 microprocessor. That is a basic processor. And when this microprocessor is invented, anybody can answer? 19? 76 or 74? 1976. Okay. And how many transistors in that 8086 microprocessor? To make a 8086 microprocessor, how many transistors are used? 29,000 transistors. 29,000 transistors. Okay. Now, okay, see, everyone see here. The simple program, A is the variable, B is the variable, C is equal to A plus B. The simple addition program, define the variables and write C is equal to A, B, C. A, B, C are variables and C is equal to write simply A plus B. That is the addition of the two numbers. Now, how we are implementing this operation in the 8086? 8086. You are studying, you are using the mobile, everyone using the mobile phones and latest laptops, right? While purchasing the mobile or laptops, the one feature we are seeing, that is the which bit processor, 32-bit processor or 64-bit or 128-bit. First specification, bit processor, right? And coming to our 8086 microprocessor is 16-bit processor. Okay, so to perform this simple addition operation, first defining the variables. After defining the variables, these variables can be loaded into registers. Register is 8-bit storage device or 16-bit storage device. If the processor is 16-bit, then that processor is having 16-bit registers. Okay, అంటే ఏంటి ఇక్కడ C language లో డైరెక్ట్ int A, int B, int C అన్నారా? Similarly, that A variable can be moving to one of the register of processor in the low end or in the advanced one లో మనం అర్థం తెలియదు అది. But basic one we can understand clearly. So the A variable can be moving to the one of the register of 8086 and B also moving to the another register. Then we are in the suitable instruction. Then we are adding. That is addition of the two numbers. We are using the instruction is add. So before writing these programming steps of 8086, we need to understand the register set of 8086 and the instruction set of 8086. No, put heading. Eight zero, 85 and 86 both are same. The difference is 8085 is the 8-bit processor. 8-bit means that can perform only 8-bit of operations. 8-bit data, what is the data range? 8 bits ante bit 0 to bit 7, 8 bits ఉంటాయి. దాంట్లో minimum data is the 0, maximum data is the 2 to the power 8 minus 1, 255. అంటే using 8-bit 8085 microprocessor, we can perform only the data. We can use the data values from 0 to 255 only. Beyond that, we can't use. That is the 8085 microprocessor. And coming to 8086, 8086 is the advanced one compared to 8085. The 8086 is the 16-bit processor. The data range is 0 to 2 to the power 16 minus 1. అంటే 2 to the power 16 minus 1 అంటే 64,530. The data range is 0 to 64,535. We can access. Beyond that, we can't access. And the remaining cases both are same. And 8085 is having the 8-bit registers, and 8086 microprocessor is having 16-bit registers, and it can perform 16-bit operations only. Right? ఇక్కడ 8 ఉంటే ఇక్కడ 16 అంతే difference. Okay. Now, put heading register set of 8086. Register set of 8086. Yes, hello. The 8086 microprocessor is having address bus. Address ante enti? Where the operand is present in the memory. If you are purchasing your mobile phone, you are seeing the one of the feature is the how much storage device. Storage capacity anta 64 GB or 128 GB or 256 GB. Right? RAM 8 GB or 4 GB or 2 GB or 16 GB. Okay. So here, if the 256 GB is there in the 256 memory location where the data is present, that location can be carried by the address bus. After identifying the location, for example, you can treat as this is the memory device. For example, data is there. For this, we are assigning some location, right? So this location can be carried by the address bus. After identifying the address, which data. So which data is available here, that data can be carried by the data bus to the registers. Okay, so that registers, it is having different registers. Okay, this is having the total 14 registers. The total 14 registers. So in that 14 registers are categorized into different thing. And the first one is general purpose. General purpose registers. This can be abbreviated as GPR, general purpose registers. So these general purpose registers are 4 registers A, B, C. So this variable can be moving to the register 1 and this can be moving to register 2. So those registers are calling as a general purpose. The general purpose, the name itself, in case of the general, no specific action. In case of general, we are using the 4 general purpose registers. That 4 general purpose registers are AX. AX register. So in this AX, the first letter indicates name and the second letter indicates size. So in that general purpose registers, the X is the one register in the 8086. So that is AX. AX is the name and X is the size. So here the name is accumulator. A is accumulator. X indicates 16-bit. So it is having the first register. This is also called the processor register. The processor using for the every operation, the by default, the AX accumulator. Okay, that is AX. The second register is BX. Here also X stands for 16-bit and B stands for name of the register, that is the base. And third one, CX, and this is counter. And the last one, data. Right? The last one is the data register. Okay, so AX, BX, CX, DX. Fortunately, the first 4 English letters, A, B, C, D. A is the accumulator, B is the base register, C is the counter register, and D is the data register. Why the names are given for that registers is the A is the accumulator, is the processor register, and B is the base. In case of memory allocations or memory access using address bus. So in that case, the base can be using as a memory location. So for that, we are using the base register. And the second one, third one is the counter. That counter is, for example, if you are using the for loop, how many times the for loop can implement? For loop is having some syntax, initialization, increment or decrement, then final value. What is the syntax for loop? మర్చిపోయారు అందరు. ఇనిషియలైజేషన్ I is equal to 0, comma I plus plus, comma I is less than or equal to, or I is greater than, I is less than or equal to 10 or 20. So initial value, incrementing or decrement, then ante step value, then final value. Similarly, the counter also, the CX register also using in that purpose. CX also using in that purpose. So that's why the CX is called the counter register. What is counter? Huh? What is your name? Pradeep. Okay. So counter is counting purpose to execute the some set of iterations multiple times, similar to for loop. So that's why that name is called counter register. The last one, data register. The DX stands for data register. On this register, for example, if you are multiplying the 12 into 12, what will be the answer? 144. The 12 is the two-digit number. 12 second operand also 12 two-digit number. But we result we are getting 3-digit. Actually 4-digit to 0 ignore చేస్తున్నాం. So the answer is 0144. In that, the first two digits can be stored in the one register. Okay, the next two digits, that is the overflow data, that can be loaded into the automatically into the DX register. So that's why the DX is called the data register. So these are the 4 general purpose registers.
Saving. And these registers also used as date register. Lower byte, upper byte. Low and high. Similarly, VH, VL, CH, to 8. Too much slot. Alright. Can be written as higher accumulator, lower accumulator. Index, and this one is
హలో మరి ఎట్లా data segment, code segment, stack segment, and extra segment. Right? The four segment registers, the each segment size is the 64 kilobytes. Write down. The each segment size is 64 kilobytes. Each segment size is 64 kilobytes. That is the core segment is 64 kilobytes. Data segment is 64 kilobytes. Extra segment is the 64 kilobytes. And stack segment also the 64 kilobytes. Okay. Next. See, if you are in the, it will be stored in the core segment. That can be loaded into the data segment and stack segment. In case of stack operations, stack segment can be using. Okay. No. So how many registers here? Any what are the total registers? Next one is flag register. See, these all registers are called yes, hello. Huh? Okay. Okay. Flag registers. The index registers, pointer registers, flag register. These are registers. They're called special function registers. And this all special function register sizes are 16-bit. Only the general purpose registers can be used as a 16-bit or 8-bit register. The remaining all special function registers can be used as a special 16-bit registers. The 16-bit registers, that is the flag also 16-bit. Now, write down the flag register. Put heading. This flag register is having the size is 16-bit size. The flag register size is 16-bit. And in this 16-bit, it is having only 9 flags. In this 16-bit, only we are using 9 bits. That's why 9 flags are there. And this 9 flags can be divided into conditional and control flags. This 9 flags can be divided into conditional flags and control flags. The conditional flags are 6 and the control flags are 3. So how many? 9 flags. Now we'll discuss this all 9 flags one by one. The format of the special function register, that is the flag register is 1, 2, 3. Okay, that is 0, 1, 2, 3. What is the size? The total 16 bits. So in this 16 bits, I will take the one example, 99 plus 35. What is the answer? What is the, how you are adding this? 99 plus 35. First we are adding this one, 9 plus 5. So while adding the 9 plus 5, what is the result? 14. So in the 14, the 4 is the sum value and 1 is carry. Okay. For the next time addition, that carry we are adding to the next addition. That is the 1 plus 9 plus 3. That is 134. The answer is 134. So if you are not considering this carry, then what is the answer? 124. Is it correct answer? No. So how the processor knows in the previous section the carry is present? Because of one flag, that flag is called CF, carry flag. Whenever you are performing the addition operation, the carry is present, that carry can be loaded into the carry flag. Okay. So now, ఇక్కడ ఎన్ని బిట్స్ సేవ్ చేసుకుంటుందమ్మా ఈ సిఎఫ్ ప్లేస్ లో? How many bits? The flag register size is 16 bit. అంటే bit 0 to 15. ఇక్కడ what is the data can be stored? ఏం పెట్టగలం ఇక్కడ? Which data we can store here in this place? Only here. Carry. How many bits? Only 1 bit. Okay. Either 0 or 1. So now this is the carry flag. Carry flag. And here we can place either 0 or 1. The 0 in the previous addition, the carry is not present. No carry. The 0 in place of CF. ఇక్కడ CF ఉండదు. 0 కానీ 1 కానీ ఉంటుంది. అంటే 0 ఉంటే ఈ ప్లేస్ లో 0 ఉంటే no carry. So here the carry is not present. అంటే for example, if you are adding the 2 plus 5, what is the answer? 7. What is the carry? No carry. So in that case, you can place the 0. Automatically the processor is placing the 0 here. But in this case, 9 plus 5, the carry can be present. That can be placed here. Adding 9 plus 3, this carry can be calculated. Okay. So that is the carry is present. 0 means no carry and 1 means the carry is present. Whenever you are performing the addition, the internally that will be added. Next, and this position we are not using, that is not implemented. That is a don't care condition. Akkada 0 unna, no 1 unna, no need to bother because that position is not defined. Okay. And the next position is PF. The next question is PF. That is a P stands for parity. Okay. What is the parity? Anyone can define the parity? Number of ones. Based on the number of ones, we are defining the parity. How many types of parity? 2 types. What are the 2 types? Even and odd parity. What is the even parity and what is the odd parity? Okay. Even means even value. That is a divisible by Odd means divisible by, not divisible by 2. That is the odd. That is the odd parity. Now, but in the 8086, but in the 8086, in 8086, we are using even parity. We are using even parity. Right? So now, ఇక్కడ ఏంటమ్మా చెప్పండి. What is the meaning of 0 and what is the meaning of 1? By default, the processor is using even parity. Okay. So if in the result even number of ones are there, even number of ones are there, then that is PF is equal to 1, even, and here odd. Even parity and odd parity. Okay. And this position we are not using, and this is called auxiliary carry. This is also called auxiliary carry. Here also same 0 and 1. This auxiliary carry and this one, the both are same. The auxiliary carry and carry flag both are same. This can be used in case of 8-bit, and this can be used in case of 4-bit. This 4-bit is called right now. So actually the auxiliary carry, the AF stands for auxiliary carry. That auxiliary carry can be used in case of nibble operation. Ante 4-bit add చేసిన తర్వాత, if the carry is present, that can be placed in the auxiliary carry. Carry can be added to the next 4-bit addition. And coming to the carry flag, the carry can be at the time of 8th position or 16th position, 24th and the 32 positions. Okay, multiples of 8 simply. So the carry is present at the 8th. What is the meaning of 8th position? What is the 4th position, 8th position? Why we are using these terms? Because we are performing the binary operations. Binary operations. The register size is, our register size is the 8-bit or 16-bit. See the register set. 8-bit registers or 16-bit registers. Ante 8-bit lo carry vaste, that is into the CF. 16-bit lo carry vachina, that will be into the CF. And internal ga madhyalo 4, 12 ఆ cases ఉంటాయి కదా, అందులో carry vaste, that can be into the auxiliary carry. So auxiliary case we are not considering. In our programming language also, we are not considering the auxiliary carry. In place of auxiliary carry, AF is equal to 0, there is a no carry. No carry present at the nibble position, that is the 4th position. And AF is equal to 1, the carry is present at the nibble position. That is, we are not considering. Internally, that can be added. Okay. So here, the same, no carry and carry is present. And this case also we are not using. Then ZF. Anybody can guess what is Z? 0 flag. Okay. So that 0 is 0 and 0 flag. When you will get the 0? In case of additions, in case of multiplications, in case of divisions. Divisions, 0 by something, 0. 2 minus 2, 0. 0 into something, 0. So in that all cases we are getting the 0. So how the processor knows the 0? Whenever in arithmetic operations, the result will get automatically, this flag will set. This flag will set. Ante, what is the meaning of this? Okay, 0 means the result equal to 0. Means result equal to not equal to 0. మీకు z ప్లేస్ లో 0 ఉంటే ఇన్ arithmetic ఆపరేషన్ రిజల్ట్ ఈస్ నాన్ జీరో వాల్యూ. z ఈక్వల్ టు 1 ఉంటే 0 అని. ఓకే, అంటే 2 - 2 ఇచ్చినప్పుడు మనకి రిజల్ట్ 1 కాబట్టి ఇక్కడ z ఈక్వల్ టు 1 ఉంటుంది. నెక్స్ట్ ఆఫ్టర్ దిస్ సైన్ ఫ్లాగ్, దిస్ ఈస్ సైన్ ఫ్లాగ్, సైన్, అండ్ హియర్ ఆల్సో సేమ్ 0 and 1. Now if you are taking the 1 bit, 1 2 3 4 5 6 7 8 bit, 8 bit data, and మీరు ఇంకా 16 expand చేస్తే it will be 16 bit. So this is called LSB and this one is called MSB. How you are representing the negative numbers? Anyone can answer? Digital లో how you are representing negative numbers? Huh? 0? 0 or 1. What is the meaning of 0 and what is the meaning of 1? Okay. So now the size of the flag register is the 16 bits, right? So in that six, how many flags we are using? 9 flags. So that 9 flag again divided into two types. One is conditional flags, control flags. So in that, the 3 flags are controlling flags. The 3 flags are trap, interrupt, direction. The three can be controlling flags. That is a trap, interrupt, direction. The remaining 6 flags, that is the carry, parity, auxiliary, zero, sign, overflow. These 6 flags are conditional flags. These 6 flags we are using in the conditions. For example, if you are using the C language, if condition, what is the if outputs? Yes path, no path, true path, false path. And similarly, this all 6 flags also we are using in that purpose. For example, in the addition operation, carry is present or not. We can check carry flag. The carry is present, C is equal to what? True. C is equal to 0, false. The condition I am using, the condition name is JNC. That is the jump no carry. So what is the condition? True value. Jump no carry. What is the true? Jump no carry. What is the true path? C is equal to 0 is the true path. C is equal to 1 is the false path. Okay. So these are the 6 conditional flags and 3 controlling flags. Right. So this is about. So how many total registers are present in the 8086? Total registers in 8086. 14 flags. What are the 14 flags? The 4 general purpose registers and the 10 special function registers. In that, the important one is flag register. Okay. So these four, using the 16, 14 registers, we are using the programs. The 614 only we are using to write a program. That is a basic programming language. Okay. Next, so in the second step, problem statement, anyhow we know. The second one is the sequencing operation, that is the flowchart. In the third step, finding the instructions. Before finding the instructions, we need to know the registers. The register set of 8086. The next one, what we need to study? Instruction set of 8086. You can keep the head. Okay, you can see the total 14 registers. 4 plus 6 plus 9 plus 13 plus 1. Total 14 registers, right? Next one, register set of 8086. Here, sorry, instruction set of 8086. Instruction set of 8086. Write down. The instruction is binary code. Instruction is binary code. The 8086 microprocessor is having the 8086 microprocessor is having the basic instructions are the 8086 microprocessor is having the basic instructions are 17 117 basic instructions. Okay, next line. Using different addressing modes, using different addressing modes, this can be expanded to over this can be expanded to over 20,000. This can be expanded to over 20,000 instructions. These instructions can be classified into one arithmetic instructions, two data transfer, line by line, right? One arithmetic, two data transfer, three logical, four shift and rotate, classified into one arithmetic instructions, two data transfer, three logical, four shift and rotate, shift and rotate, next control transfer instructions, control transfer, then flag manipulations, fifth one mission control instructions, and the last is string, string, string instructions. Okay, so these are the different classifications of instructions. The first one is, first we'll study the data transfer. Data transfer instruction. Now, hello. The first one is the data transfer instruction. In that, under instruction down, move, M-O-V. Everyone right? Move. The instruction is move. Under syntax, everyone write down. Under syntax, move space. Don't write the space. Give the simple space. Move space. AX comma BX. Move. The instruction is move. The syntax of this move is move TR comma SR. That is simply move comma BX. DR stands for destination register and SR stands for source register. DR stands for destination and SR stands for source register. So here the BX is the source and the AX is the destination. And what is the meaning of this? Is the data can be transferred from SR to DR, source to destination. And similarly here AX to BX. The BX content can be transferred to the AX register. Okay. For example, AX is equal to 1, 2, 3, 4. BX is equal to 4, 5, 6, 7. Now you can write the move AX comma BX. After executing this instruction, what will be the AX data and what will be the BX data? Before executing that move AX comma BX, what is the data? Initial game item 1, 2, 3, 4, 4, 5, 6, 7. Then after executing this move AX comma BX, what is the AX content? 4, 5, 6, 7, 4, 5, 6, 7. The source is the remain same. Simply copy paste. Copy paste. The BX content can be copied and pasted to the AX register, right? But only the destination can be changing. This is the first data transfer instruction. The next one is push. 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 What is the push? What is the push operation? Huh? Inserting the data into the stack memory. Okay. The pushing operation means data can be insert or pushing to the stack register. The syntax of push operation is PUSH push space AX. The syntax of push operation is PUSH space AX. That means the content of AX can be pushing to AX stack pointer, stack memory. Okay. What is the after reverse operation? Pop. Pop. Write down. The pop, the data can be deleting from the stack to the register. Okay. So that is the push means syntax is push AX, push AX. The push means you can take the stack here. This is the stack. The AX push operation can be pushing the data here. The pop operation means deleting the stack, and that deleted data can be popping to the AX register. That is the push and pop instructions. And one more, XCHG. The syntax of this is XCHG AX comma BX. Anybody can tell me what is the meaning of that XCHG? Exchange. Exchanging the content of BX as well as AX. Move operation and chudandi. Move lo only the destination register can be changing the content. But in the exchange operation, the both can be changing. మీకు ఇనిషియల్ గా AX లో 1, 2, 3, 4, BX లో 4, 5, 6, 7 తీసుకుంటే ఏమవుతుంది? After executing the exchange information, the AX is the 4, 5, 6, 7, and BX is 1, 2, 3, 4. Right? That is exchange operation. Next. ఏంటం నాకు ఎవరు చెప్పలే ఇక్కడ? Pop. Okay. Push and pop. Exchange. Next. Load. The syntax is Anybody can tell me what is the load? Load. What is the meaning of general load? Load means storage నుంచి register లో చేయడం. అంటే here the syntax of load is load AX comma memory. The content from the memory can be loaded into the AX register. అంటే మెమరీ నుంచి AX లో పెడతాం. దట్ ఇస్ ద లోడ్ ఆపరేషన్. స్టోర్ అంటే రిజిస్టర్ నుంచి మెమరీలో ప్లే చేస్తారు. దట్ ఇస్ ద స్టోర్ ఆపరేషన్. ఓకే, ఇన్ 8085 microprocessor, to access the memory we are using only the load and store instructions. Okay, but here directly also we can use the memory in the, we will understand clearly in the programmings. Okay, so now that is the store operation. Next, one more instruction down, LDS. The next data transfer instruction, LDS load DS register. Load data segment. Next one, load extra segment. The memory can be loaded into the DS register. The memory data can be loaded into the ES register. Okay, so these all are the data transfer instructions. Next one, what is the next one? Arithmetic instructions. The second category, arithmetic instructions. So what are the basic arithmetic operations? Addition, subtraction, Engolo. Okay, the arithmetic operations. Basic arithmetic operations are addition, subtraction. Simply addition, what is the spelling? ADDITION. Here the instruction also we are choosing from that spelling only. The first three letters. That is the addition is ADD, addition instruction. And similarly subtraction, SUB. And multiplication, MUL. And division, DIV. And the two more extra instructions are there. That is ADC and SBB. ADC stands for add with carry. Present you are adding the 16-bit. ఈ 16-bit లో వచ్చిన క్యారీని నెక్స్ట్ 16-bit కి యాడ్ చేయాలంటే then you can use the ADC. That means the ADC can be used to used in the series of addition operations, multi-byte operations. The ADC can be ADC and SBB can be used in the series of addition and subtraction or series of or the multi-byte addition and subtractions, ADC and SBB. Then multiplication, division. Okay, so these all are. And the two more instructions here, INC D. What is INC? What is INC? Increment, increment. Okay. The syntax of add AX comma BX. What is the meaning of this? AX is equal to AX plus BX. AX is equal to AX plus BX. Right? The content can be added, that is the AX content, and BX content can be added, and the result will be stored in the AX. And similarly, AX comma BX, that is AX is equal to AX minus BX. And here also same, AX comma BX is equal to AX is equal to AX plus BX. Is it correct? What is the difference? ADD and ADC? Add with the carry. So here plus CF. The carry flag content also added here. Okay. And SBB AX comma BX is equal to AX is equal to AX minus BX minus CF. Borrow. In case of, if you are taking the borrow in the previous subtraction, then we need to subtract that borrow from the current operation, current number. Okay. So that is the subtract with borrow. Next, coming to the multiplication, this is a somewhat different. In addition and subtraction, how many registers we are using? In addition and subtraction, how many registers? 2 registers. The 2 registers, one is AX, BX. What is the AX? What is the name of the AX? Destination register, and BX is source register. So in case of addition and subtraction, we are using the 2. in arithmetic operations, for example, we are performing the addition operation. Carry can affect or not affect. Addition lo carry వచ్చే chance ఉందా లేదా? There is a chance, right? So carry will affect. Next, parity. Number of zero change అవుతాయా సేమ్ ఉంటాయా? 2 plus 4 ఎంత? 2, what is the 2 binary value? 0 0 1 0. 6 binary value 0 1 1 0, right? అంటే 1 1 ఉంది, 6 లో 2 ones ఉన్నాయి. So the 2 is the parity, is the odd parity, 6 is the even parity, right? Now you can add two results, 2 plus 4 result ఏమొస్తుంది? 2 plus 6 8 వస్తుంది. అక్కడ ఎన్ని ఉంటాయి? 1 8 కదా, 1 1 0 0 వస్తుంది. సో 1 0 0 అంటే how many? What is the parity? Odd parity. So result change అయిందా? So in addition, carry flag will affect, the parity also will affect, auxiliary carry also will affect. Carry effect ఏంటంటే auxiliary carry also will affect. And sign flag also will affect. చేంజ్ అవుతుంది కదా sign. ఓకే, నెక్స్ట్ 0 will affect. ఎఫెక్ట్ అవుతుందా కాదా? 2 plus 4 అంటే నాన్ జీరో కాబట్టి z ఈక్వల్ టు 0 ఉంటుంది. అదే సబ్ట్రాక్షన్ చేస్తే 2 minus 2 వేస్తే ఎఫెక్ట్ అవుతుంది. ఓకే, సో దట్ ఈస్. అండ్ ఓవర్ఫ్లో క్యారీ ఎప్పుడైతే వచ్చిందో ఆటోమేటిక్ గా ఓవర్ఫ్లో ఆల్సో విల్ సెట్. సో వాట్ ద ఫ్లాగ్స్ ఆర్ ఎఫెక్టింగ్? all 6 conditional flags are affecting while performing this all arithmetic operations. And coming to logical operations, also same. Parity will change, no carry. No carry in the logical operation. There is no carry, there is no auxiliary carry. And the remaining all flags will affect. The remaining all flags will affect. That is the parity flag, zero flag, sign flag, and overflow flag. The 6 flags are affecting. The one more instruction is there, and carry effect of all flags will affect in logical operations except carry and auxiliary. Result change అవుతుందా సేమ్ ఉంటుందా? లాజికల్ ఆపరేషన్స్ చేంజ్ అవుతుంది. చేంజ్ కావడం కోసమే we are performing the logical operations. Result operation and all this. And one more instruction is there, test. Right down everyone. The last one is test. T-E-S-T. T-E-S-T. Syntax is test AX, BX. Test AX, BX. Now, write down. In test operation, the logical AND operation is performed. In test operation, the logical AND operation is performing, and the flags are affecting. Flags are affecting, but the result is not saved. Result is not saved. See here, AND operation AND, comma AX, comma BX. For example, you can take, I will take the simple 4-bit data. 1 2 3 4. 1 2 3. Data is a 0 1 1 0 1 0 1 0. What is the answer? You can perform the AND operation. This is the AX and this is the BX. Perform the AND operation. 0 0 0. 1 1 1 1 0 0 0 1 0. This is the answer. So AX is equal to this result. In the AND operation, the result can be stored in the destination register AX. And test also same. Test AX, comma BX. Here, the date, this can be performing same, but the result is not saved. Only the flags are affecting. After executing this AND operation, the AX content will be modified with the result. But coming to the test operation, not saving. Same. ఇంతకుముందు present ఇక్కడంతా 011 ఉంటే ఇక్కడ కూడా 0110 అనే ఉంటుంది. Only the flags parity, zero, overflow, sign flags will affect. ఎందుకు సైన్ ఫ్లాగ్ అంటే మనకి ఈ ఎంఎస్బి పొజిషన్ లో 1 ఉంటే చేంజ్ అవుతుంది, 1 ఉంటే 0 ఉన్నా చేంజ్ అవుతుంది. దట్స్ వై దిస్ జెడ్ ఫ్లాగ్ ఆల్సో, సైన్ ఫ్లాగ్ ఆల్సో విల్ ఎఫెక్ట్. ఓకే, సో దీస్ ఆల్ ఆర్ ద లాజికల్ ఆపరేషన్స్. నెక్స్ట్ కీప్ హెడింగ్. నోట్ చేసుకుంటారా? సార్. What is the next category? What is the number? 4 or 5? 4. Shift or rotate. Yes. Shift or the rotate instructions. Shift or rotate instructions. అయిందా మీరు? Okay, the shift and instructions. Write down. List of the all shift instructions. SHL. Write down one by one. పడట్లేదా? Write down. One is SHL. Next one, SHR, SHL, SHR, ROR, ROL, ROR, ROL, RCR. Next one, RCR. Next one, RCL. These are shift and rotate instructions. SHL stands for shift left. The data can be shifting to left hand side. And the SHR means shift to right operation. ROR means shift, rotate right. And rotate left. And the RCR and the RCL is rotate right through left, rotate right through, sorry, rotate left through carry, rotate right through carry. Syntax of road shift is AX comma 01. For example, you can take the simple register. Okay, listen. How many bits we are shifting? How many bits? Not here. SHL AX comma 0. One position we are shifting. To which side? Left hand side. So this is right and this is left. So the bits can be moving like this. So what will be the here? So that is 1, 0, 0. And here 1. That is losing. And the carry lo untundi, lose avutuntam adi. Next, what will be the here? Logical shift. Insert zeros here. How many positions you are shifting? That many zeros you can add to the right hand side. Data ni right to left move cheste, you can add the zeros at the right hand side. And similarly, SHR operation. Next, ROR. Rotate right ante 1, 2, 3, 4. Okay, ఎలా మూవ్ అవుతుంది? 1 0 1 1 0. Okay, so which operation? Rotate right. Rotate right అంటే ఇలా, ఇది ఇక్కడికి వచ్చేస్తుంది, ఇది ఇక్కడికి వచ్చేస్తుంది, ఇది ఇక్కడికి, ఇది ఇక్కడికి, ఇది ఇక్కడికి. ఇక్కడ డేటా లూజ్ కామ్. ద సేమ్ డేటా విల్ బి రొటేటింగ్ లైక్ దిస్. ఈ రొటేట్ అయ్యే ముందర క్యారీలో కూడా వస్తుంది సేమ్. క్యారీలోకి వస్తుంది, సేమ్ బిట్ విల్ బి లోడెడ్ ఉంటుంది హియర్. ఓకే, సో వాట్ ఈస్ ద రిజల్ట్ హియర్? 0 like this, 1 0 1 1. ఇక్కడ ఈ 0 ఎక్కడిది? మనం యాడ్ చేసింది కాదు. దిస్ ఈజ్ రొటేటింగ్. దట్ ఈస్ ద రొటేట్ రైట్ ఆపరేషన్. రొటేట్ క్యారీ అంటే, క్యారీ అంటే ఇది ఇందులోకి వచ్చి ఇందులో ఉన్నది ఇక్కడికి వస్తుంది. ఇప్పుడేమో రొటేట్ రైట్ లోనేమో ఇక్కడ బిట్ సేమ్ ఉంటుంది, ఇక్కడ రొటేట్ అయ్యేది సేమ్ ఉంటుంది. ఆర్సిఆర్ అంటే ఇక్కడ మూవ్ అనేది ఇక్కడ వస్తుంది, ఇక్కడ ప్రీవియస్ ఉన్నది ఇక్కడ వచ్చేస్తుంది. ఓకే, దట్ ఈస్ ద రొటేట్ అండ్ షిఫ్ట్ ఇన్స్ట్రక్షన్స్. నౌ ఫర్ ద టుడేస్ క్లాస్ we are closing. Now you can ask me the doubts. The open interaction session. పోయిందా? రాయట్లే, రాస్తుంది, నువ్వు రాయట్లే. Yes, hello, hello, please maintain silence. If you are asking doubts only, you can leave the class. Otherwise, sit here only.